Hello guys, welcome back. And for this videos, we're going to continue for our mathematics study application of differentiations. So for this part, of course, we're going to first learn what is mean by tangent and normal, and then what do we mean by stationary points. Then later the maximum minimum problem, and last is rate of change. So let's do it, and hopefully you can cover more than I planned for today. And first one, 10a, tangent and normals. So first thing you should guys notice the tangent and normal, they are just perpendicular to each other. So the gradient m1, which is tangent, m2, which is normal, m1 times m2 always give you -1. Okay, and this tangent line gradient, I hope you guys remember dy dx, okay, or I should say derivative is the tangent line gradient. So in this such case, my gradient m use dy dx to figure it out, and then it also can be tangent theta, and same time it also can be raised over 1 y2 minus y1 over x2 minus x1. Okay, done. And look at example 1. Find the equation of the tangent to the curve y equals x cubed plus half x squared at point x equals to 1. So in such case, I change it to dy dx. So it's 3x squared plus x. So it's my dy dx. And the gradient of the tangent x is just like 1 with x equal 1. And I plug in, I get my derivative, or I get my tangent line is 4. So after that, I plug all this thing in the equation of the tangent. So I get my m is 4, but just remember for this point, I have to plug it back, back to the original equation to get the point. So I plug 1 inside my x cubed plus half x squared to get 3 over 2. Okay, this is the point I required or I need. Then I get my y equals 4x minus 5 over 2. So the normal line, see over here, recall from chapter 2. And hopefully you guys can remember that. m1 times m2 just equals -1. And the tangent has a gradient m, so my normal will have the gradient as -1 over m. Okay, so if the question is asked, okay, find the equation of the normal to the curve, again, first we find the tangent, so we get dy dx. So in this case, we get 3x squared minus 4x. Then my initial or tangent line gradient is 1, right? -1 over -1 is 1. So, sorry, my my bad. My tangent line gradient is 3 minus 4, which is -1. That's why my normal line gradient is +1. Then I plug in, I got y equals x minus 2. Okay? And example 3, same thing, but they are just using, the rational powers. So make sure you know the TI spice or like casino class-pad to know how to directly plug a tangent line function in to get the equation, because this is pretty important, because normally for final year exam 2, they only ask us to have like 1 mark for this question, so you directly plug in CAS to get all the values. Okay, and for example 4 and 5, essentially they are the same thing, but they just involve with circular functions. And again, as I mentioned before, if you look at these examples, make sure you use paper or any books or your pad, just cover the solutions to try yourself, okay, to see if you can get the same answer as the example solutions. So if it's the same, then check the process, okay, to see if you are using the same approach. If not, decide which one is better, or you can learn from it. Or maybe even you can give the better approach to this kind of problems, okay? So this is the learn from the examples, because essentially you cannot really send your teacher or even send me, I mean, every question you have, we cannot really respond to you to as a time manner. So you can learn from the textbook and from the examples to explain, self-explain, right? Okay, just to learn this one. And for example 6, this is a bit tricky because uh, if we want to find the equation of a tangent line, but uh, actually in this case the tangent line gradient doesn't exist because it's just x equals 0, but it's definitely a tangent line. But this tangent line, it just simply means this gradient is not existing. Okay, and this is 10a. Make sure you guys know how to use cache or how to use hand to solve for this kind of equation. So 10b, again, like we emphasized, even in 9a, our average rate of change is y2 minus y1 over x2 minus x1, or in this case is fb minus fa over b minus a. So the same thing is instantaneously rate of change. It's just like at that certain point, it's a derivative. Okay, so if they gave us a time interval, which means 1 second to 5 seconds or 3 seconds to 5 seconds, you always use average rate of change. If they give us a point, or like x equal 2, or maybe like x equal 5, then it's just like simply means like derivative. Okay, and example 8 is just like the real world problems, just to make sure for part B, for how long this model be valid. So essentially just means our volume V can never be less than 0. So my V is always greater than or equal to 0. Okay, and same thing apply to example 9, and you can get your dt over dt temperature corresponding to time rate of change, and plug the number required to get the answers. So on the page 424, this one, the motion in a straight line is really, really, really important for math method, because this is normally we use involved with applications. Okay, so velocity is essentially means the rate of change corresponding to position and time, and acceleration just use describe how fast your velocity change. So it's a velocity derivative respect to time. So if I give you guys this one, our x is mean by position, v mean by velocity, my a mean by acceleration. So in case is d over dt, x respect to time derivative, we have a. V respect to time derivative, I have my acceleration. So in this part, the anti-differential part is what we will learn through chapter 11 and 12, maybe. I think in chapter 11, but in later. So until now, we just need to know this part, okay? And for our math method, the luckily thing is our position always, always gives the equation as time, okay? So if we want to solve any problem, we just do derivative or we do anti-differentiation later. So for this one, and first they ask at what time and what position the particle will have zero velocity. So if we derivative it to get the dx dt, then we plug in what we want to get all the things required. Okay, so example 10 is pretty straightforward. And sorry, let's just finish this one. And the acceleration at those instants. So again, they ask for the acceleration, which is make acceleration equation. Again, derivative for velocity. So acceleration is actually means by second derivative respect to x. Okay, but this idea again is not emphasized in math method, but it's worth to know that. And we plug t equals 1 and t equals 3 to get the answer. And finally, we want to know when acceleration is 0, velocity is the velocity value, so I plug in. So in this case, the negative just means the direction is change or the direction is opposite as what we defined as positive direction. Okay, it does not mean the value, it just means the direction. And another thing is just always check the unit because we are doing the real world problems. Okay, and hopefully this video is helpful. And next one, we're gonna go through the stationary points, okay, which is another really important part for our derivative applications. Okay, if you guys think my video is helpful, please click the like button and share with your friends. And thanks for watching, guys. See you for next videos. Bye bye.